Hi everyone. So before I get into the lecture, navigation needs coordination. Um, I'm just going to talk a little bit about what is needed to wrap up Module 4, Week 7. This lecture video is coming a little bit later in the week than it normally does, but we still have like pretty normal due dates and references, so we should have already gotten through the reading, which was the rest of chapter 4 in the text. Everyone participated in the guest lecture with Paulina Close on Tuesday, which was great. And then there is this lecture video, Navigation Takes Coordination. You all will also need to participate in discussion 7, which is centered around the guest lecture with Paulina Close. So that'll be due October 13th by 11:59 p.m. The lab that we're working on this week is working with spatial reference system, which is the second tutorial at the end of chapter 4 in the text. This is also due October 13th by 11:59 p.m. I also went over this lab extensively in the open lab that was offered this past Thursday. The recording is up on the module homepage, but I'll also include it on the lab assignment page. And again, the Module 4 Quiz 2 has been canceled, so no need to worry about getting a quiz done for this week. Just focus on getting the discussion in and the lab. And I'll just throw in a couple of spatial reference questions on the quiz for next week. Okay, so let's go ahead and get into the lecture. The first part of the lecture will be a little bit of review. We'll be talking about coordinate systems, and so some of this material should be pretty familiar, and we'll go a little bit in depth when we start talking about conversions and looking for location and distance. So coordinate systems are used to precisely locate a place on Earth, and there are two basic types of coordinate systems that are really important for mapping, and those are geographic and projected. So we have our geographic coordinate systems, and these are spherical and are based on spherical globe coordinates, and they're measured in degrees of latitude and longitude. And then we have our projected coordinate systems or grid coordinate systems, and these convert spherical coordinates to planar coordinates. They use a set of mathematical equations, and it projects a three-dimensional surface coordinates onto a two-dimensional map. We also have land partitioning systems, which we'll get into later in this lecture. So geographic coordinates, so like I was saying, it's based off of latitude and longitude reference to a place on Earth, and it's usually given in degrees, minutes, and seconds, or DMS. So we'll remember that latitude is going from north to south. I like to remember it as latitude is like a ladder, and so we start at the equator, which is 0, and then if you go north from the equator, it starts at 10 north and goes all the way up until 80, and this is all positive. Anything south of the equator is going to be negative, and that could be seen here in this little graphic. And then we have longitude, and the way that I remember this is that these are long. They go from pole to pole. So you have your meridians. And so again, we have our prime meridian, and this has been accepted as the standard 0 meridian for longitude. And so as we go west of the prime meridian, we start here at 10 all the way to 180. And those are going to be negative, and then everything, all the longitudinal grid lines going east of the meridian, also 10 to 180, are going to be positive. So these are based on a sexagesimal system. So that means that this is a base 60 numeral system. We are used to using base 10. And so this is important to remember and keep in mind when you start to add and subtract different lat and long coordinates, that we're doing this off of a 60 numeral system instead of 10. So we could think of this as in time and lat and long. Each unit is divided into 60. So we have our Latin long notations. Degrees are divided into minutes and seconds. So when you see the notations, the degree symbol will be used. And then minutes and seconds use what we would normally see for feet and inches. So again, that's kind of a new notation. So the one little quotation mark is minutes, and then the double quotations are seconds. And so when we're writing our Latin long out in degrees, minutes, seconds, this is what it's going to look like. So this is going to be 40 degrees of latitude, 51 minutes and 59 seconds north. And then we have our 124 degrees longitude, 4 minutes, 58 seconds west. And that same notation in decimal degrees is 40.886516 and negative 124.082840. And again, this is a negative number because this 124 degrees is west of the prime meridian, therefore it is negative, and this latitude 40 is north of the equator, therefore it is positive. So when we're looking at a map like a USGS topo map, which is what we have been using in our labs, there's a bunch of different information along the neat line of the map, and there's multiple grids that we're basing those notations off of. And so all of that information could be found down here, and you'll see that when you're doing the lab this week. I want to take a look at this supposed neat line. And so there's a lot of information on here. So for one thing, we can see the full notation of those latitudinal degrees up here in the corners and down here in the corners. I'll go ahead and start at the bottom just because it makes a little bit more sense when I start talking about our 2.5 minute tick marks. And so we'll see with our 44 degrees, because our neat line is within that 44 degrees, or our map data is within that same 44 degrees. We're not jumping latitudes right now. When you get into the middle tick marks, they won't include that initial degree because we already know we're within 44 degrees. So when you see a notation like this where it says 44 degrees and 30 minutes, and there's no seconds included, that just means that there's 0 seconds, and you just assume 0, 0 here. And so this map is split up between 2.5 minutes in latitude and in longitude. And so when you go up to your next tick mark, that is going to be 44 degrees, 32 minutes and 30 seconds. So that is 2.5 minutes plus added to that 44 degrees and 30 minutes. And then the next one is another 2.5 minutes at 35 minutes. So again, that's 44 degrees, 35 minutes. And since there's no seconds, that's 0 seconds. And then the next tick mark up is another 2.5 minutes. So we could have 44 degrees, 37 minutes, and 30 seconds. And so it works the same way with longitude. So we can see our full notation of longitude up here. We have 123 degrees, 22 minutes and 30 seconds. And we are going backwards here a little bit, but we know that 20 is 2.5 minutes less than 22 minutes and 30 seconds, and so on and so on. All right, so let's talk about calculating latitude from our degrees, minutes, and seconds. So we know that 1 degree of latitude is approximately 69 miles, and 1 degree of latitude also equals 60 minutes. And so we can determine by that information, we would divide 69 by 60, which gets us 1.15. So then we know that 60 minutes is 69 miles, or 1 mile equals 1.15 miles. Calculating longitude is a little bit different. It's not as straightforward because, as we know, the meridians get closer as we move towards the poles. So the meridians are really close together at the poles, and then they spread out and get wider towards the equator, and then they come back down again and get closer towards the South Pole as well. So fortunately, there's a pretty easy formula to figure out our longitude, and we do that by knowing our latitude. So this is the formula here, and this is the part, again, is determined by latitude. So you'll take your 1 degree of longitude, and that will be equal to cosine the degree of latitude times 69 miles. Okay, so here's an example of how to convert from degrees, minutes, seconds to decimal degrees. So we'll need to remember that each division, minutes and seconds, is 1 to 60 of the division above it. So we'll start out with 40 degrees latitude, 51 minutes and 59 seconds north. And so we'll start with our seconds, and we divided 59 by 60, and that gives us 0.98. So now we tack that 0.98 onto our minutes, so that gives us 40 degrees with 51.98 minutes, essentially. So then we'll take that new number, 51.98, and divide that by 60 as well, and that gives us 0.87. So our decimal degrees is now 40.87 degrees north. And to convert back, you just do the reverse process. I'm not going to go over that quite as in detail, but these slides will all be available in PDF form for you to reference shortly. Okay, so let's go over distance to degrees, minutes, seconds. So we're working with north to south right now. So our formula is miles multiplied by 60 minutes divided by 69 miles, and that is going to give us our minutes of latitude. So if our map distance is 20 miles, we'll have 20 miles times 60 minutes divided by 69, and that gives us 1,200 minutes over 69. And then we need to simplify it, which gives us 17.39. And when I say simplify, I just mean we're dividing 69 into 1,200. So 1,200 divided by 69 gives us 17.38889. Remember, we're rounding up, so it ends up being 17.39. And then we're getting that back into our degrees, minutes, and seconds. So we multiply the decimal by 60, which then gives us 17 minutes and 23 seconds of latitude. Okay, so let's do our distance to degrees, minutes, and seconds doing east and west, or longitude. So it's a really similar formula, but there's a few differences. So we have our miles multiplied by 60 minutes divided by the miles at latitude, and that is going to give us our minutes of longitude. So again, that map distance is 20 miles times 60 minutes divided by 53.83, which is what we just got in our previous equation. And then we will do that cross multiplication, which gives us 1,200 minutes over 53.83 miles. And so then we are simplifying that, which gives us 22.29 minutes. And then we're converting back to decimal or degree, minutes, and seconds, which gives us 22 minutes and 17 seconds of longitude.